Since we have three terms or three classes in our categorical syllogisms, we need three intersecting circles to represent those classes. The minor term, the major term, and the middle term classes of our arguments. The author has an unnecessarily complicated way of referring to these segments. You can forget about that. We'll just number them the same way all the time so that we can refer each other to the different parts of the diagram. 1 through 7, like so. So let's see if we can focus on different parts of this diagram to the exclusion of others, so we can tell what we're looking at. Circle S is composed of segments 1, 2, 4, and 5. Agreed? That's where there may be S's, members of the minor term class. Circle P is composed of segments 2, 3, 5, and 6. That's where there may be members of the major term class. Circle M is composed of segments 4, 5, 6, and 7. So that's where we might find members of the middle term class. Now, in what segments could there be S's that are not at the same time M's? That would be segments 1 and 2. In what segments might there be S's that are at the same time M's? That would be the intersection of S and M, 4 and 5. Where might there be M's that are not at the same time S's? 6 and 7. M's that are S's, 4 or 5 again. Members of the major term class that are not at the same time members of M, segments 2 and 3. Members of the major term class, or P, that are at the same time members of M, 5 and 6. Where might there be M's that are not at the same time P's? 4 and 7. M's that are at the same time P's? 5 and 6. And then the relationship between S and P. S's that are not P's, 1, 4. S's that are P's, 2, 5. P's that are not S's, 3, 6. P's that are S's, 2, 5. So do we all recognize those different portions of our three-circle diagram? Any questions about that? Well, these books have a specific series of moods and figures that they use to teach us this proof procedure. So when we diagram these 5 or 6 syllogisms, we should encounter every little glitch or problem that's possible in this procedure. So the first one that he has in mind is the AAA1. Categorical syllogism. Now, do we practice taking that mood and figure and then reconstructing the argument form that it represents? Did we do that last week? Okay, well, let's brush up on it. You begin by putting the middle term where it belongs in the first figure, so you have to know that. It's in the subject position of the major premise, predicate position of the minor premise. The major term P has to occur in the major premise. There's only one place for it to go. The minor term S has to occur in the minor premise. There's only one place for it to go. S and P are always the term letters of the subject and predicate of the conclusion. So you finish off that structure by supplying the quantifiers and copula indicated by the mood. They're all A propositions. So no matter what mood and figure were presented, it's that same procedure all the time, over and over again, to get from the mood and figure to the structure that it represents. Now, our definition of validity says this argument form is valid if, whenever all the premises are true, the conclusion can't be false. Not only do we not know if they're true or false, we don't even know what they are. because they're purely symbolic. But when we diagram a proposition, we are diagramming its truth. So we're going to diagram these two premises. That will be a symbolic representation of the first part of our definition of validity. That will represent whenever the premises are true, no matter what they are. Then we're going to see if they establish the truth of the conclusion. If they do, that's a proof that the argument form is valid. If they don't, that's a proof that it's invalid. Now, sometimes it matters what premise you diagram first. When it does, I'll let you know. It doesn't matter in this case. So we'll start at the top with the major premise. Now, some of you might find it helpful, and this is not necessary, it's not part of the procedure, but you might find it helpful to take the two circles involved in that premise out of the three-circle diagram. It's less busy. And we'll call those segments A, B, and C. So you should be able to diagram this premise on the two-circle diagram. All M's are P's. Do you remember how to do that? We're going to crosshatch segment C, correct? We did those diagrams last week, right? Okay, you got to know that. So that's a diagram that says that it's true that all M's are P's, because we find every remaining portion of circle M, that is segment B, existing within circle P. But you need to do that on the three-circle diagram. So you should be able to locate the corresponding segment on the three-circle diagram, and that would be segments 4, 7. That's what needs to be crosshatched. So there's our first premise diagrammed. Move to the minor premise. All S is M. You might find it helpful to take those two circles out of the three-circle diagram. It's a little bit simpler. Again, we'll call those segments A, B, and C. So we should be able to diagram that proposition, that premise, on the two circles. All S is M. Let me get that out of the way. That would be cross-hatching segment A. Agreed? Well, that's what we need to do on the three-circle diagram. So locate the segment on the three-circle diagram that corresponds to A. And that would be segments 1 and 2. This is a symbolic representation of that first part of our definition of validity. Whenever the premises are all true, that's what that represents. The truth of the infinite number of substitutions for those premises. So if that argument form is valid, those true premises must establish the truth of the conclusion. In other words, the relationship that all S is P must now be indicated on the three-circle diagram. For that to be indicated, every remaining portion of circle S must be found within circle P. So what remains of circle S? 5. And is 5 entirely within circle P? Yes, it does. So our true premises have established the truth of the conclusion, and they always will, because that diagram is going to be the same no matter what that argument is about. So that's how we read an example of this proof procedure for validity. Any questions about that? Good. I think next up for us is an AAA2. We're on page 216 now if you're interested. AAA2. Okay, so go ahead and if you need help, ask your partner, somebody sitting next to you. Get to work on reconstructing that argument form indicated by the mood and figure AAA2. So you're going to begin by putting the middle term in the second figure. That's the predicate position of both premises. The major term, P, must occur in the major premise. There's now only one place for it to go. That's in the subject position of the major premise. The minor term of the argument, S, must occur in the minor premise by definition. There's only one place for it to go. It's in the subject position of that premise. S and P are always the term letters for the subject and predicate of the conclusion. So now we just finish it off by supplying the quantifiers and copula indicated by the mood AAA. Again, they're all A propositions. So our quantifier is all, and the copula is. Draw another three-circle diagram. We'll always number those segments 1 through 7 in this order. Sometimes it matters which premise you diagram first. When it does, I'll let you know. It doesn't matter in this case. So we'll start at the top with the major premise. All P is M. If you like, take those two circles out of the three-circle diagram. Call their segments A, B, and C. And diagram that premise on the two-circle diagram. When we diagram all P as M, we're going to crosshatch segment, that's right, A. Locate that same segment or the corresponding segment on the three-circle diagram. Yeah, you should recognize it as 2, 3. That's what needs to be crosshatched. Minor premise. If you like, take the two circles out. Label their segments A, B, and C. All S is M. On the two-circle diagram, we'll be cross-hatching segment A. Locate the corresponding part of the three-circle diagram. You should find that to be 1, 2. So this time, let's pause and make a note. We've already established there is nothing in segment 2. But you still have to diagram both of those segments, 1 and 2. And you want your cross-hatching to be perpendicular, parallel, and the cross-hatching of two premises to be perpendicular. This is so you can read the work of each premise independently when checking over. There's another reason for going over for cross-hatching segment 2, but it doesn't concern us right now. So this segment, A, corresponds to 1, 2 on the three-circle diagram. That's what gets cross-hatched. So again, that satisfies the first part of our definition of validity. That argument form is valid if, whenever the premises are all true, the conclusion cannot be false. So that's a symbolic representation of whenever they're both true. This argument form is valid if they should establish the truth of the conclusion. If not, it's a proof of invalidity. Our conclusion says all S is P. In order for that relationship to be indicated in the three-circle diagram, every remaining portion of circle S must be found within circle P. So what remains of S after our cross-hatching? 4 and 5. Are 4 and 5 both contained within circle P? No. Then it does not indicate the relationship of our conclusion. That conclusion is not true. That's a proof of invalidity. Questions about that one? He has next in mind for us the AII3. Are you having any difficulty remembering how to get from the mood and figure to the structure? If you are, consult your neighbor or your book. You always start out with your middle term in the correct position, according to the figure. In the third figure, that middle term, M, is in the subject position of both premises. Major premise must contain the major term P. There's only one place for it to go, predicate position. The minor premise must contain the minor term S. There's only one place for it to go, predicate position. Predicate position. S and P always for the subject and predicate of the conclusion. Finish it off by supplying the quantifiers and copula according to the mood. The major premise is an A proposition. That's all it is. Minor premise is an I proposition. Do you remember that quantifier and copula? Some is. And the conclusion is an I proposition. So some is again. Draw another three-circle diagram. Number your segments, 1 through 70. So ladies and gentlemen, in this case it does matter which premise you diagram first. It matters when one of your premises is universal and the other is particular. That's quantity. The universal propositions are the A and the E. The particular propositions are the I and the O. So we have a universal major premise and a particular minor premise. So we're going to be diagramming the major premise first again, not because it's a good place to start, because we have to. If they're both universal, it doesn't matter which one you diagram first. If they're both particular, it doesn't matter which one you diagram first. So all M is P. Oops. What shall we crosshatch on the two-circle diagram? Segment C. The corresponding part of the three-circle diagram is 4, 7. So that's what gets crosshatched. Our first particular premise to be diagrammed tonight. Let's see how to do that. You know we have to use an X to indicate the at least one S that the quantifier sum refers us to. It has to be inside of circle M because the premise says it is an M. At the same time, it has to be an S. It's an M that's an S. So we'll put our X in segment B. Now notice that segment B on the three-circle diagram has been reduced to simply segment 5. Yes? Mm-hmm. Yeah, is 5 still the intersection of S and M? Yes. Sure it is. So that's where our X goes. Again, that is a symbolic representation of the first part of our definition of validity. This argument form is valid if, whenever all the premises are true. That's a representation of that much. Then the conclusion cannot be false. So if valid, they should have established the truth of the conclusion. Let's see. The conclusion says sum S is P. For that to be indicated in the three-circle diagram, two conditions have to be met. There has to be an X inside of circle S, because the proposition says it's an S. We do have an X inside of circle S. The second condition is that that same X has to be inside of P at the same time. It's an S that's a P. So is our X part of both circles S and P? Yes, it is. It's an S that's a P. Those premises have established the truth of the conclusion. It's a proof that this argument form is valid. Questions about that one? AII2 is next. Okay, so you can you get from the mooted figure to your argument structure? Go ahead and do that. Right. Major premises in A. Minor premise in I. Conclusion and I. We're ready to go. Draw your three-circled Venn diagram. Number your segments. Again, we have one premise that's universal and one that's particular. No matter which one of them is universal. I know it happens to be the major premise again, that's inconsequential. The universal one has to be diagrammed first. So, all P is M, we've done that a couple times already. We'll be cross-hatching what segment? A. Okay, the part of the three-circle diagram that corresponds to A is 2, 3. Aside from that rule about diagramming the universal before the particular premise, here's one more rule that you have to remember. And it's kind of wordy, but it sure does describe the situation exactly. And the rule is, when you have a choice of two existing segments in which to put an X, you have to put the X on the line that creates those choices. Let's see what I mean by that. If we were to diagram some S as M on a three-circle diagram, that X is going to go in segment B. Notice that segment B is composed of existing segments. By that I mean neither is cross-hatched. Existing segments 4 and 5. So the X has to go on the line that creates 4 and 5 out of B. You all see what line that is? Right there. Now, to be on the circumference of circle P means this. It either is a P or it's not a P, but we don't know which. That's what it means to be on the line. See, our premises don't say anything about it being a P or not. They just say the S is an M. So that's all we're allowed to diagram. So now let's see if the truth of our conclusion has been established. It says some S is P. Two conditions have to be met. There has to be an X inside of circle S. Is that X inside of circle S?
Yeah.
It sure is. It also has to be inside of P at the same time. Is that X inside of P? No, it's not. When the X is on the circumference of a circle, it's neither in nor out, to our knowledge, of that circle. We don't know if that's a P or not. Got it?
So it's not valid?
It's invalid. The conclusion is established with 50% certainty, which is 100% invalid. See, deductive arguments either succeed or fail. It's all or nothing. So if this were an inductive argument, depending on what it is, 50% certainty for the conclusion might be great. But that's for inductive arguments. Deductive arguments either succeed or fail, and this one has failed. Now we did this next one in the first class, and I'm not sure why the author has selected it. It doesn't show us anything particularly interesting. So I'm going to show us two more moods and figures that you know, you do have to make note of some peculiarity of your diagram. So the first one would be my choice. I'll say I will make it a 4. That will make it a 1. Okay, go ahead and reconstruct the argument form. You see how this is the same thing over and over again. Very simple set of instructions. See, middle term in the first figure, arranged like so. P in the major premise, S in the minor premise. S and P always for subject and predicate of the conclusion. Finish it off with your quantifiers and copula according to the mood. Major premise is an A. Minor premise, A. Conclusion, I. Draw your 3-circle diagram. I take it that camera's rolling. Is it? Okay. It doesn't matter which premise we diagram first. Start with the major premise. All M is P. I think crosshatch segment C. What do you think? Yes. All S is M. I would say crosshatch segment A. Forgot to carry that over. Sorry about that. Now, in order for that conclusion's truth to be indicated in that diagram, two conditions must be met. There must be an X inside of circle S. Is there an X inside of circle S? No. So the first condition is not even met. That conclusion's truth is not indicated in our diagram. So let me point something out to you. You're not permitted to interpret the diagram as follows. Well, segment 5 is part of S, and it exists, so there must be S's there, and they're in P. No, you must read the particular quantifier sum in terms of an X in the appropriate segment. There is no X at all, let alone in the appropriate segment. So our diagram does not say sum S is P. Can you remember that? Do you understand my explanation? Yes?
So if we're looking for validity and we see that it's AAI, we instantly know that's invalid.
Wait, say that again?
If we were looking for validity in these statements and we see that it's AAI, we see that it's invalid immediately, right? And same with AAO, it would be invalid.
Why do you say that?
Because it would be another particular, and so, oh wait, maybe not, because I don't know the graph.
No, you're good. Did you read ahead by any chance?
No, I was just thinking.
Well, this is a fallacy that we're going to learn a little bit later. It's called the existential fallacy. So, yeah, that can be determined on site. We're not quite there yet. That's good. All right, I'm going to throw you a little loop here.
Yeah, question.
Ooh, yes.
I was just going to ask why it was called that,
Called what?
the existential fallacy.
Because a mathematician, logician, George Boole, interpreted the English language as follows. Universal propositions don't necessarily indicate the existence of any S's. Don't. But the particular proposition, particular quantifier sum, does mean, in normal English, there is at least one. This allows us to speak of mythical creatures without being committed to their existence. We could say all unicorns have a single horn on their forehead without being committed to the belief that there are any unicorns. But when we say there's some unicorns in my backyard, our meaning is there exists at least one. So from universal premises, which don't necessarily assert the existence of any members of S, cannot conclude that there does exist at least one. That is the explanation, the existential fallacy.
So it lies just in the fact of existence. It doesn't have anything to do with the connotations of existential.
Well, it has to do with the universal quantifiers, not necessarily implying the existence of anything. Whereas that one specifically says there is at least one in existence. That's it. It's a subtler interpretation of English. Aristotle, the guy who started all this a few thousand years ago, thought that was valid. But more modern consideration of language, it's out. No good. That explanation is in your book. Check it out. Let's see how you do with this one. IOI4. I'll lag behind a little bit. You guys a chance to knock it out. Fourth figure. Major and minor terms. Subject, predicate at the conclusion. Quantifiers and copula. You should have that. I want to see what your diagram looks like. Having trouble locating those X's? You should be able to tell where the X goes on a two-circle diagram. If that segment on the three-circle diagram consists of two subsegments. It's got to go in the line that creates those subsegments. So you almost can't go wrong if you're having trouble with the X on a line. You almost can't go wrong if you start out with two circles. Anybody done? No?
I don't feel confident.
You don't feel confident? Okay, well, let's see. Sum P is M.